Great. Okay. My name is Kay. I look after training and education at Makers. And I came to Makers to shift from software engineering into teaching. I found myself really inspired by the journeys of our developers. And one of the biggest challenges that I noticed is that people and organizations, particularly the greatest of them, sometimes don't get the best out of each other, which I think is a real shame because human history shows us, and we'll talk about some of this today, that organizations aligned with their people can achieve the most incredible things. And that's what drives me in my work here at Makers. So on to the talk. This talk is about why top tech companies have such strange recruitment practices. Why do the likes of Google and Facebook have these sort of very intimidating or at least arduous interview processes, and why do candidates put up with it? Why does Netflix, for instance, ask people to leave at the first sign of underperformance? And why does Amazon bring people in from totally outside the hiring team and give them veto rights over every hire? In this talk, I'll explain the logic behind some of these practices, why hiring great people alone isn't enough, and how Makers can help you achieve similar results without compromising on your values and totally changing your recruitment practices. I'll do this by taking a quick detour through engineering history and explain a theory from economics. And there will also be a small section on fried egg sandwiches. So I hope you aren't feeling too hungry. You've had your breakfast. Otherwise, it could be a bit trying. Let's get into it. Start with some history. So this is a photograph of the Rogers Commission, which was assembled in 1986 to investigate the Space Shuttle Challenger disaster, which was a catastrophic explosion on launch of a space shuttle that resulted in the deaths of all on board that day. It's a terrible, terrible disaster. And this commission who investigated this disaster included the astronaut Dr. Sally Ride, who was the first American woman and, so far as we know, first LGBT person in space, along with Neil Armstrong, who's second from left here, and the physicist Richard Feynman. Now, there's a long tradition of engineering disasters being used to advance the industry and ensure such failures can never happen again, and this is no exception. So this group of people uncovered many powerful ideas, including the idea of the normalization of deviance, which is the phenomenon of poor practice gradually becoming more and more acceptable as small infractions don't immediately lead to disaster. And this idea remains a really important one in the healthcare industry to this day. But they also uncovered, I'll wait for this slide to actually show up, they also uncovered the precise mechanical cause of the failure. And you might think that in a space shuttle, which is a very complex machine, the cause of this failure must also be quite complex. But in fact, it's quite straightforward to understand it, and I'll explain it now. The rocket's boosters vent a lot of hot gas, which is how they generate this upward acceleration. And to avoid this gas escaping through small gaps in the components and destroying them, they use rubber rings that squish and seal under pressure. So your home plumbing may also use the same principle. Now, this launch took place on the morning after quite a cold night. And so the physicist Richard Feynman found a sample of this rubber, and he took it home and he immersed it in some similarly cold water. And he found that at this temperature, the rubber became quite stiff. And this meant that the gases then vented through the gaps around this rubber, eventually totally destroying the seal and causing the disaster, which you can start to see happening in this photograph in the highlighted area. You can see that black smoke coming outside. And the thing to really pick up about this is that it's a small, relatively simple piece. It's not a big, complex thing. So fast forward to 1993, this Nobel Prize-winning economist, Michael Kremer, was inspired by this investigation. And out of his research, he proposed a theory called the O-ring theory of economic development, which is the central idea that I'll focus on for the rest of this talk. And at the core of this theory is the observation that complex modern products of industry can, like the shuttle or this engine shown here, becomes totally sabotaged by the failure of even one small component, like that O-ring. For these products to be any use at all, every component has to be up to scratch. And so every person working on it has to be doing great work, even if their job seems relatively unimportant in the grand scale. Kremer called these O-ring products. Another example of this is cooking. You might have experienced the problem of accidentally oversalting your food, and there's very little you can do about that other than just start again. And so in a team of top chefs, every single one depends on the work of every other to be top-notch. And that means that fine food is an O-ring product. Likewise with software. When I worked on a software team, I would regularly be amazed to open up the contributors list and see people I'd never met, perhaps people who no one at the organization still remembered. But occasionally, while fixing a confusing bug, I would encounter problems in their work that I would then have to go back and fix. Now, of course, this happens with even the best engineers sometimes, but the point is, since each element of a software project relies on many others, each engineer also relies heavily on many other engineers doing a good job. From this idea, Kremer derived a simple formula for product quality. Now let's consider a really simple case. This is where the food comes in, by the way. Let's say that you and I are making a fried egg sandwich. I'll fry the eggs and you toast the bread. But we're not very good cooks, and so there's a 50% chance that I'll burn the eggs and a 50% chance that you'll burn the toast, which ruins the whole sandwich. Now, because these failures compound, they essentially need both to be good for the whole product to be good, we multiply the percentages. This is what Kremer came up with. And this means we can only produce great sandwiches 25% of the time, not 50. And so you'll see if we had to add more steps, we'd barely make anything edible. If it was a BLT or something, somebody else was cooking the bacon. I believe it's a component of a BLT. So now let's take it to a more complex level. Let's consider some relatively highly skilled software engineers with a 95% chance of doing great work and a 5% chance of making a mistake somewhere that needs to be unpicked later. What's counterintuitive about this picture is that even with these much higher skilled people, the quality still isn't anywhere near 95%. Because mistakes compound in teams building Oring products where each worker is highly dependent on each other's work, the result is much lower quality than you'd expect. You can see this play out with what software teams call regression. So you add a new feature and something else breaks and these mistakes actually add up. Now let's look at a couple of other examples. One where the quality is a bit higher, 99%, and another where it's a bit lower at 90%. And the differences are again dramatic. 4% higher quality in the engineers produces a 20% higher quality output, whereas 5% lower quality produces a 21% lower quality output. Now this is still quite theoretical, but actually it'll explain a few things that we already see to be true about talent in organizations. Our first insight is that if we can get everyone in the team a little bit better, the quality of the output significantly improves. The product you're shipping to customers, which in this age of digitalization, the product that's becoming much more important is dramatically better. Now, next we'll talk about what makes this so fiendishly difficult to do with normal hiring practices. So let's imagine that you are in a team of good but perhaps not great peers, producing average work as a result. You're considering whether it makes sense to grow and become better at what it is that you do. In yourself, you do care about doing great work and you would like to do better. But when you try, you find that your new skills have only a small impact on the overall quality of the output. Even worse, since the product is not dramatically better, it doesn't sell dramatically better, and so the additional resources your organization has to spend on your pay and your growth are also not that much greater. Even if they paid you more than your colleagues, the return on investment limits how much can actually be done in a sort of business sense perspective. And this brings us to our second conclusion. In a team of average skill, exceptional growth by any one engineer won't yield exceptional rewards. They'll still be disappointed by the results that their team can achieve for their customers. Now, maybe some people think like that, but all of us here, we're sort of conscientious people, and I'm sure everyone in your organization is too as well. And we strive to do great work regardless of the situation. But then what happens? Because your team is producing average work, not only are you disappointed with your personal impact, but your team gets given less important projects. And as a result, you start to get a bit demoralized. Even if you're highly paid for your team, you're paid less than your colleagues in other organizations with better people. Your department's results also limit your company's investment in your growth. And in summary, your talent is not yielding the results that you know it can. And so you start to dream of a much better team, another team where you're working with other highly skilled people, and as a result, producing much better work. Not only will this be more fulfilling, your organization will be better performing and so have more money to spend on your pay and growth. And so you leave to join this high performing team somewhere, which is so much worse for your manager, who is hoping that by hiring someone brilliant, that they could turn things around. And this explains the common aphorism, which I have in my head, but I just realized this morning comes from Steve Jobs, which is that great people want to work with great people. They're not only more fulfilled, but their employers, reaping the rewards of highly performing teams, can offer much higher compensation. And as a result of this, performance tends to persist. In these complex, highly integrated products where each person influences the success of every other person, average teams tend to stay average. And while great teams do have challenges to stay great, greatness is theirs to lose. Now, all of our organizations exist on a continuum of skill, makers included, and it's useful to be able to work out where it is that you sit. And so I'm going to lay out three differences. The first and most important one is that talent tends to move from lower to higher skill organizations, wanting to work with better people on more fulfilling projects and to be better compensated. So look at the CVs that are passing your desk. Are they from organizations that you respect? And where are your levers tending to go? Secondly, observe how your team members relate to each other. Do they feel that they can only truly do great work alone, or do they relish the opportunity to collaborate? And thirdly, observe how they engage with L&D opportunities and then how long they stay afterwards. Now, all of this is, pretty miserable. And at the start, I promised not just to talk about, the logic behind this, but also what you can do about it. And that moment's now come. Top tech companies do solve this problem, but they don't solve it by normal hiring alone. So I'll first talk through what the big tech firms do, and then tell you about how we at Makers can help you do it as well. So Netflix is, renowned as a high talent organization, and it's not that way by accident. After losing a third of their staff in the dot-com crash, they made it their mission to retain only the very best. And so they asked people to leave freely and easily if they're not meeting the bar. In fact, they've built their culture around this. And they even did this with their co-founder, Patty McCord, who actually developed a lot of this culture in the first place. Now, this is not a good approach for many organizations. This would be quite disruptive in the normal company. We certainly wouldn't do it at Makers. Amazon, on the other hand, have a practice they call bar raisers, and these are interviewers brought in from outside the hiring team, outside the team that is hiring, to be part of every hiring process. And their express aim is to ensure that every new hire is better than 50% of people in the organization in similar roles. And they have veto rights over any and all hiring decisions. And this approach is somewhat more practical for the average company, although certainly not without some challenges. And this is what we do, Makers Pathway. With Makers Pathway, we help you raise the bar in your engineering teams with brilliant junior talent. And we do this by finding incredible people who want to make the jump to a new career. These are people who've done amazing things already, but who employers won't hire for such a small reason as the fact they don't have tech skills yet. Of course, we can give them those. We've had media talent agents, a movie director who worked with Idris Elba, educational psychologists, startup founders, business owners, refugees, aerospace engineers, far more than I can name in this talk. And we work with them for 3 months and see how they thrive in computing, challenge them, and give them strong engineering values to ensure they are always delivering high quality work, even if it's on smaller O-ring type projects. We then select the ones who are a really good fit for a given company and send them to your teams. We only send great people, and so you know that your team is always choosing from a top-notch pool. They then work for us on contract to you for the first year, after which you can hire them permanently. And this co-branding helps you beef up your employment offer with the high standard of training that we're known for. And these candidates, they're excited to work with us, which makes them excited to work for you. And throughout this first year, we provide them with professional coaching to help them navigate any challenging situations in the workplace and raise them then with you to help you increase the chances of retention. And we provide bar raising technical coaching and mentorship to ensure that they keep their standards high, no matter what engineering environment they might enter. Here are 2 people we're really proud to call Makers. The first is Imtiaz. I worked with Imtiaz on the pathway, and it was a really fascinating experience. I was halfway into my first session with him, and I realized I'd spend most of the time answering his questions rather than asking him any. Really, really smart guy and beloved by his team, promoted to a senior role in just 2 years and now helping Global Relay expand their new London office. Alishka, we might hear more about later. She studied at Makers after 7 years of consulting. And, of course, this is a massive boost to her capacity at Deloitte, leading to a very compelling career trajectory. And these are the sort of stories we want to create more of with the pathway. But the real magic is what happens when you stick with it over time. We discussed how it can be difficult to take brilliant people and place them in an existing team. But since the pathway is a sustainable talent pipeline rather than just a one-off, you can make a real impact on effectiveness over time. Here's an example of how it can play out if you take 2 junior developers from us per year to replace your natural attrition. In year 0, your team is performing at an average level. In year 1, we placed 2 makers with you, raising quality a small amount. And now we're assuming that due to the challenges we mentioned before, some of the makers we'll send you will move on too. And so in year 2, 1 maker leaves and 1 is promoted to mid. This, along with 2 new junior makers, starts to raise the bar. And in year 3, this continues to build. By year 4, you're starting to attract better external senior talent as well, which we can also help with. Now, this isn't just a diagram. This is actually how it's played out with one of our longest standing partners, Deloitte. Deloitte have been regularly hiring makers for 5 years, and we're really proud to be working with them. And we've invited Martin Espelli, a partner at Deloitte, to talk to you today about how makers have helped them drive improvement and raise the bar. And so this is the point at which I hand over to Martin and stop sharing. Thank you.